So we have covered the evaluation, the timers, the assignments, analog and digital assignments, the conversions, quality type conversions, the averages, and the last feature of the calculator that I'm going to demonstrate to you is the output to input conversion. Why would we need an output to input conversion is a common question. Basically, the output to input conversion is a message that's coming from one master to another master or a couple of masters. So let's say that there is two masters that are sharing the control over a set of bays or a set of points, and they need to communicate to each other as to which master is in control or which master is controlling those shared resources. The way it's done is we make a digital output available to both masters, and when one master basically forces that digital output, that's a message that gets converted into a digital input, and that digital input can be retrieved or polled, if you like, by the second master. So master 1 and master 2, we've got master 2 that's gonna pick up that value and basically learn whether the first master is in control of the shared resources or is not in control of these shared resources. If you have more than one master, then instead of doing a digital output to digital input conversion, you can do an analog input to an analog output into an analog input conversion. So this way the analog output would be set by one master that would give the control to any of the available masters if there is more than one master to pick up the analog input value. So if the analog input the analog output is set up to 2 and the analog input is then picked as 2, which means that master 2 has the control on the shared resource, or if the analog output is set up to 3, then the analog input would be set up in turn to 3, and the third master would have the control over the shared resource. This is an inherited functionality that was very successful in the D2X platform, and it's inherited and translated in our D400. Now, one thing to notice is that both points, the source and the destination, would be owned by calculator. So you just have to decide on what is the source point type and what is the target point type, and then calculator will pick the next available point slot that will be assigned these points as a digital output or an output to input conversion. So just to demonstrate this, we're picking digital output 1 of calculator and we're converting the value to digital input 6 of calculator. So if I go back into my point summary, okay, and we go into the applications this time, directly into the calculator. So under the calculator, we can go to the details, and in here we're looking at 2 points. We're looking at the digital input point, okay, so we're looking at the digital input point, which is an output to input conversion, and we're looking at the digital output number 1. When this digital output number 1 is basically latched on, if I go back to my digital inputs, I'll find my digital input number number 6 turned on, okay? And in the same manner, when that digital output changes, if I change it back to latch it to off, okay, I go back to my digital input and my digital input changed to off. So this digital output that's owned by calculator changes to a digital input that is also owned by calculator. With this, right next, we're going to show you how these points are going to be transferred to masters or to slaves.